Okay, today we're going to talk about how to determine equations of quadratic functions using certain information given to you. So we will be working with all three forms, standard, vertex, and factored. So let's put it all together, and we're going to start by determining the equation of a parabola given a graph. So when I'm given information, the first thing I need to do is choose which form I'm going to work with. When I'm given a graph of a parabola, I can easily see some things that might not be apparent with other forms. For example, I can clearly see that the vertex here is 3, 4, and that tells me a lot about the function because I also know, okay, I know where my axis of symmetry is, so it's pretty clear here that h is 3 and that k is going to be 4. So in this case, I'm going to start with form number 2, vertex form. And that's convenient because the first information I got was the vertex. Now, we don't know anything about A, so at the moment we can't write anything in, but we can start here. We've discussed in the past the difference between a variable and a parameter, and we know that x and y are the things that we call variables. Okay, and then the thing that we call a parameter is going to be A. So A is the thing that we're still looking to find. And the way we do that is, well, we need some more information, so we need to sub in a point on the graph. And this can be any nice point on the graph. Sometimes they're not great, but I can see actually that this one looks pretty good. So I'm going to sub in the point 5, 6. And then I should write this in a final form. So I know that y equals 1/2 x minus 3 squared plus 4. If I want, I can do a check by subbing in another point on the graph, but right now I don't think that's necessary. So let's take a look at B. In this case, I know my two x-intercepts, and I know another point that my graph passes through. So, okay, I know that my graph passes through, say, -1, 0 and 7, 0. And I also know it passes through the point 2, 10, so somewhere up here. What I can do is, because I know the x-intercepts, I'm going to use factored form of my equation, okay? And in this case, we were calling that number 3. Okay, so what I can do is I can start with y equals a x plus 1, x minus 7. And it's really, really important here that you include that a value. This is a common mistake, guys, forgetting to put that in. But what this does is it still represents the vertical stretch, compression, reflection of your graph. We haven't really discussed this in factored form yet, but of course that number is the same as the number in your vertex form. So it still has the same impact of stretching, compressing, or reflecting your y values. So again, we're going to need, we already have our parameters 1 and -7 in there, but we still need to figure out what a is, and we're going to do that by subbing in a point. Okay, so it's not the prettiest number, but that's fine. Just remember, we still have to give ourselves a final answer. All right. And I get questions sometimes about what form I want the answer in. If I don't specify, you're allowed to pick, but it has to be correct. Now when we look at C, C is exactly actually like part A, except we don't have a graph, like a picture to look at. But we do know that we're starting with a vertex and we have another point. So again, we're going to start with form number 2, y equals, and we are going to sub in what we know. Okay, and be careful with your sign here. That should be -9. And now we're going to sub in the point -5, -46. So what happens when we're given 3 points and we know our parabola passes through them? In this case, we are going to use form number 1, standard form. And actually, we have seen this before. Basically, this is just giving us a table of values of points that this parabola passes through. And if you recall, we've done this before by just subbing in these points into our standard form. So for example, I'm just going to rewrite it in this form, a form we're more used to. And I know when I sub in 1, -7, I'm going to get a plus b plus c equals -7. When I sub in 5, 93, I know my y value is 93. And finally, and what we did with our system here, it is a system of equations, is we created an input and an output matrix for this. In number 2, we're given information about a parabola that has more to do with the physical features than particular points on the graph. So we're going to draw a little diagram here to help us. Okay. So it says here a quadratic function has an axis of symmetry x equals 4. And intersects the y-axis at y equals 3. And intersects the x-axis at -1. And x equals p. Find p and the coordinates of the vertex. Okay, so by the definition of an axis of symmetry, we know that the distance from our first x-intercept to the line x equals 4 should be the same as distance from P0 to x equals 4. So this is if you remember all our talks on reflection, okay, this is a reflection about the line x equals 4. So basically, I know that P is going to be equal to 4 minus -1 plus 4. So I'm taking the difference. So I'm taking the difference between the point and the x-axis, and then I'm adding it to x equals 4. Okay, therefore, 9, 0 is on the graph. We're just looking for the p coordinates, which we found, and we're looking for the vertex. So how do I find the vertex? Well, actually, I do need the equation of the parabola in order to do that. So I'm going to start with factored form. And the reason I start with factored form is because I know the x-intercepts. So by zero product property, I know the formula in factored form. So now I'm going to sub in the other point I know, which is 0, 3. So now that we know the equation of the parabola, we should be able to figure out the equation of, or the coordinates of the vertex, because we already know that the x-coordinates of the vertex, xv, have to be 4, because that is our axis of symmetry. So if I know that xv is 4, I can find yv by subbing that into our formula. Let's take a look at number 3. So in number 3, we have actually been given an equation, so we do not have to take that step in deciding which of the 3 we are going to choose. The question is asking find A and K so that the given points lie on this particular parabola. So what you will notice is that we know that x equals 1 is our axis of symmetry. Not that we're necessarily going to use that in our question, but basically we know our h value. H equals 1, right? And it's asking us for two other things. It's asking us for K, A and K. So if I have two unknowns, that means I need two pieces of information to get me two equations, and they are right here. So I'm going to take these 2 points and sub them in for x and y to create a system of two equations and two unknowns.